So that's simulation generative, and now we'll move on to the last topic of what's new in manufacturing. Okay, so as I said, plenty of additive and subtractive manufacturing inside Creo 10. Additive, been lots and lots of changes since the first release of support for additive manufacturing back in Creo 3, where we could send models directly to supported printers. The big thing was in Creo 4, in the introduction of the lattice feature. I guess that's been enhanced across many releases of Creo, adding more and more lattice capabilities, different shapes, different types of lattices, performance improvements, a whole bunch of stuff around the lattice. Okay, so inside Creo 10 now we have more lattice shapes in there. We've got the two new auxetic cell shapes that have been added to the lattice feature. So the rhombic with diamond and an elongated dodecahedron. Okay, so they can be controlled by dimensions there. There's also 3 new beam-based cell types, so the rhombic with diamond, and elongated dodecahedron as well. So also some options, some randomization inside that. Okay. So in terms of what auxetic materials are, basically auxetic materials are materials that essentially move the material flows towards the point of impact rather than away from the point of impact. So they're quite useful in terms of defense, biomedical, packaging, things like helmets and stuff, where when there's impact, you want more material to go in there to help stop, impacting, okay, absorption of energy. So plenty of studies into this. So there's some new auxetic lattice types inside Creo 10 now, if you have that requirement for your materials. Okay. The other one was the formula-driven lattices. Okay, so formula-driven lattices were introduced a couple of releases ago inside Creo. So there was the gyroid, primitive, and diamond cell types in there. So essentially these are self-supporting structures, so they don't need any support material. They're defined by very simple equations, as you can see down here in the bottom of the screen. So plenty of study going into them. Okay, so inside Creo 10 now, they've added the iGraft and wrap package graft, the IWP, which is a triply periodic minimal surface cell. So it's similar to the gyroid. So it's basically helping, companies develop, lightweight structures for thermal fluid structural applications. Okay. So another option that's there inside Creo. Okay. Something else that's been added in. So back in a few releases ago in Creo, I think it was 7, PDC added the ability to have varying beam thickness based on simulation results for your beam-based lattices. The idea is you could run a simulation working with the loads where hollow the model out with a lattice feature, and then you could apply the simulation results so it would actually make the beams thicker where they were needed and thinner where they weren't needed. So that capability has also now been added to the formula-driven lattices, as you can see here, where we've got a thinner lattice over down this end and a thicker lattice down this end where the higher stresses are. Okay. Lots of stuff happening in additive manufacturing, but of course subtractive manufacturing, there's plenty going on there as well. Okay, so inside Creo 10, one of the big new things is the now supporting barrel tools. Okay, so these are basically, these work in conjunction with some specialized 5-axis finishing sequences, wall or floor axis. So basically barrel tools, as you can see the screenshot over here on the right hand side. The geometry is slightly different, so you get greater engagement between the cutter and the workpiece than a conventional ball nose mill. Okay, so basically they can allow some massive improvements in terms of machine time, as you can see, 90% depending on the geometry that you're dealing. Okay, so there's some new options for them. Also in the subtractive manufacturing side, the Creo high-speed machining option that was introduced back in, I think it was Creo 5. So that's PDC working in conjunction with ModuleWorks to bring their technology in. So this is an additional module that added in some initially 3-axis high-speed machining, but a couple of releases, I think in Creo 8, we added in 5-axis machining as well. So there's a couple of new options being added in Creo 10 for the for the HSM rough and rest roughing sequence. Okay, so basically some ability to now reference a mill volume rather than just a mill window. So that works across all the different 5x HSM rough and rest rough, and also the 3+2 tool paths. Okay. And I guess at the back end as well, there's been a bunch of sort of just general toolpath calculation improvements. Okay, so back in Creo 6 was introduced, not 5. Back in Creo 6 when this was introduced, a constant load toolpath that took 9 minutes and 50 seconds. Now inside Creo 10, that same toolpath will take under a minute and a half to calculate. So massive improvements in performance calculation. There's been also a big focus on turning inside Creo 10 on the NC side of things. So there's some other options introduced, support for 2-axis heads a couple of releases ago. So now in terms of playing the cut line player back with those synchronized steps, so working that through, accessing that in the player. The hole making sequence, Daniel's going to show a little bit of this. So basically when you're working with lots of holes in your model, specifying which holes you might want to remove, exclude out from that particular hole making sequence. Some other options around streamlining the process of manual cycling, also tool offsets. Okay, so basically specifying some axis offsets some offsets along the tool axis, I should say. P-print, so chucking all your stuff out into your code. So now all of the tool parameters can be exported, written out through P-print statements. Cut compensation support at each slice and area turning is shown here. Also, we can define, there's the option for defining a clearance distance for area turning. So it gives you kind of 3 different feed rates essentially now. There's a rapid feed when you're approaching, a plunge feed, and a cut feed. So again, getting more efficiencies out of your tool paths. And also defining turn profile, start, end, driving the cut direction for your area group. Okay, and lastly, a bunch of new options around your tool offset in relation. Okay, so plenty of stuff there in both additive and subtractive manufacturing. So I'll hand you back to Daniel, and he's going to show us his last little bit. So Daniel, back to you.
All right, thanks, Alan. Let's have a look at additive manufacturing now. Again, here we've got the model of the Hills helicopter and the gearbox assembly. I'm just going to go and hide this cover and zoom in on this disc part down here. Now, the disc part down here is, has always been 3D machined and manufactured. Firstly cast and then machined. Now, with the ability of 3D printing and the new capability, we would like to go and replace this feature over here with and these holes with a new lattice. All right, so before we do that, I'm just going to go and suppress the pattern of those holes, and let's just go into the start orientation. Let me just zoom out here. Okay, so now that we've suppressed it, I'm going to go and start my lattice design. All right, now we want to go and say replace the body, and before we can replace it, that's obviously way too big. So let's just adjust the sizes. And okay, so we've adjusted the sizes. Let's just go to the cell fill. Ball diameter, we're going to make 3, and because of that, this is going to be 1.5. Okay, the cross-section size. And as you can see now, it's the correct size. We can go and view that and place it into that area. And here we've got our lattice there. All right, so we can obviously also go and do the 2D lattice as we've done, for a long time now. We can go and add that 2D lattice. Let me just go back to the lattice design. All right, now that we've had a look at the 2.5D, let's just go back to beams. Okay, let's go and have a look at some of these new types. I just want to have a look here at my cell type and my cell fill. Sorry, this has jumped back to 27, so I just want to make that 1.5 again so that we can get that there. All right, now if we go back to our cell types, okay, this lattice shape is the rhombic dodecahedron lattice shape. Let's just go and adjust our cell fill here. Now, you'll see here just before I go and do that, we've got control over the skewing angle as well as the distortion here. The cell fill, I'm just going to change that to a ball diameter of 3 millimeters, and we will have a look, and that would look, we go and preview that. That is our dodecahedron, rhombic dodecahedron lattice type. Okay. Let's just go back. All right, now the next one that I'd just like to go and highlight here. Now we've also got the elongated dodecahedron type. Now, you know, these type of lattices are used in the medical device industry. They really like these type of rhombic structures. Again, you've got the skewing angle that you can control here and the distortion. All right. Now we can again go and have a look at this one, how this one looks. If we we'll place this lattice in. Okay, now again, just one other thing that is really nice is if we go and run a structural analysis on this and we find high stress areas, we can actually go and modify the density of these lattice and control the density in the areas where we need a bit more stiffness, for instance. Now, the next one that we'd like to go and highlight is the auxetic type of lattice. Now, this auxetic type of lattice here that I'm showing here is the auxetic with two angles. So you see you've got the skewing angle, and you can control the X angle and the Y angle. Now, these type of auxetic lattice type is really good for structures. Specifically, it has or specifically used in the you know, armor industry and so forth, where absorption of energy is really important because it has a negative Poisson's ratio. So you know, that's really good in things like armor design, helmet design, and it's also very popular in the medical industry. The last one that we're going to have a look at here of the auxetic type is this one here, but now it's just got the skewing angle and the X angle that we can control. And we can go and apply these type of lattices as well. All right, now the last one that I want to say the second last one. Now we've always had the formula-driven lattice type, and we've always had the gyroid lattice type. Now, if I go and just change this to, let's say, 1 millimeter, we can see here's our what we call, and you know, Alan mentioned it earlier, and he's good with these names, but it's called the triple periodic minimal surface cells lattice. Now, these ones are really good because they're self-supporting. They're good for thermal, fluids, and structural design. And it's actually quite a nice looking lattice type. And again, just as I said, self-supportive. All right, but these ones we've always had for a while. The new type that I'd like to go and show you now is called the IWP lattice type. Now that stands for iGraft and Wrapped Package Graph. I don't know who comes up with these names, but in any case, so this is what this one will look like. And again, the nice thing about this type, this IWP lattice type, again, it's self-supporting, it's good for thermal, fluid, and structural applications. And here we can go and have a look what that one looks like. Also a really nice, nice design lattice type, and also self-supporting when you're 3D printing it. All right, so that's all I wanted to show on the additive manufacturing. So I'm just going to finish this up. And next, we're going to move on to our subtractive manufacturing and go and have a look at some of the advancements made in machining. So before we do that, I'm going to close this model and just give me a few seconds and I'll open up a manufacturing model. All right, so here we've got our manufacturing model. Now this is Creo Machining 10. Now there's been a few enhancements here. Now the first one that I'd like to point out, now for you people that use Creo Manufacturing will appreciate this. For the others that don't use Creo Manufacturing, I'm sorry to hear that. But if you may be contemplating purchasing or using Creo Manufacturing, please do have a look at it. A lot of advancements have been made and improvements to Creo Manufacturing in Creo 10. And again, the biggest advantage is if anything changes in a model, it automatically updates your toolpaths. So it does cut down on manufacturing and design and manufacturing time. All right, so quickly, the first one that I just want to show you here is if we go and play the path of the ring holes. Okay, now I'm going to slow this down so that you can clearly see here. So play that. Now you'll see it goes and cuts all the holes that we specified of a certain size. Now it cuts the outer ring, the fixture ring, which is this yellowy color, beige color, and then the actual component, it goes and draws those holes as well. But in this case, what we want to do is we want to go back and edit definition this toolpath and say, well, look, in the past, if we specified the holes, it'll go and find all those holes. But now we've got additional control. Now we see the hole count here is 31 holes. And if I go to the details now, new in Creo 10, I go to the options, I can go and say user defined models, and my ring fixture, this yellowy beige part on the outside, I want to remove that. I do not want to go and cut that right now. Now I can always bring it back. But now you'll see it automatically picks up the 7 holes. And if we then go and play this path, you will now see that it only cuts the part of the ring part that we want to go and draw these holes out. So again, a small thing, but for you guys using it makes a big difference because it's easy now to go and control which holes are being drilled and which holes you maybe don't want to drill at all, or you maybe want to drill it later. Okay, so let's just say we're done on that. Now, the next thing I want to go and show you is there's been some advancements made in the 5-axis machining. Now, I've already created these volumes here. I'm just going to hide this volume here. Now, if we go and look at high-speed machining, so here we've got our high-speed machining, roughing and re-roughing and rest roughing and finishing and so forth, these different sequences. But in the past, we always had to go and do a window to go and do high-speed machining, where with Creo 10 now, I have now got the ability now, I'm just going to do it again just to show you guys, but we can now go and create a mill volume, okay, on high-speed machining, for high-speed machining. So I'm going to extrude this. I'm going to extrude on that surface, and I'm going to go and say, all right, I want to use that edge, and I'm going to use that edge, select that, okay, and accept that, flip it around to go in the other direction, okay, and we've now created that volume. Now I can go and say, trim that volume and use that ring part of ours to trim that volume. And if we go and shade it, that's what that volume is going to look like. So it's quite a funky shape there, but that's not what we actually want to go and show. So I'll just say done, return there. And now we've created that volume. Now I'm just going to suppress that volume because we've already got them up here. But now, because we've got that volume now, I've just hidden it here in the model tree, but it is still there. But now if I go and run this toolpath that we created, this toolpath to go and machine, now we've set that toolpath up to go and machine the volume, not a window, that volume. So I'm going to slow it down as well. And here you can go and see that we're machining out that volume, okay, in high-speed machining. So again, a really nice improvement made on the volume milling within Creo 10 and high-speed machining. Now, the last improvement or enhancement that I'd like to show you is this wall finishing tool. Now, if we, just before I run that wall finishing tool, if we go and look at our high-speed machining, we've got these two new sequences, a wall 5-axis finish and a floor 5-axis finish. Now, I'm going to edit definition on this wall finish here and just go and show you. And if we go to our tool manager, and I'll go and say, look, I want to create a new tool, you'll see that when we go and create a sequence of these, the wall or floor 5-axis machining, we can now use these new types of tools, which is barrel taper, We've got a barrel tangent. We've got a taper ball mill, and then the normal ball mill. But these barrel taper and barrel tangent tools, it's shown a 60% increase in machining time or decrease in machining time. Let me rather say that when using these type of tools. Now, I've already set this tool up, and it's a barrel type of tool, and I'm going to go and run this sequence and just show you. I'll slow it down. It is slow. So I run in, and then I've got a helical step down, and there we're running that tool on the 5-axis, on that new 5-axis sequence. Okay, so again, some of the nice advantages of Creo manufacturing in Creo 10. And again, the biggest advantage for you guys that are maybe using different programs for manufacturing, but designing with Creo, is if any changes are made, the toolpaths automatically update. Okay, so that's all I want to show for now on the subtractive side on Creo manufacturing.